Good day, class, and welcome back to ESI 124N, your Engineering Mechanics 2 or your Dynamics of Rigid Bodies. And for today's lecture video, we're going to talk about the planar kinetics of a rigid body, work, and energy. We're just going to develop formulations for kinetic energy of a body and define the various ways of a force and how coupled do work. Apply the principle of work and energy to solve rigid body planar kinetic problems that involve force, velocity, and displacement. And lastly, how or show how the conservation of energy can be used to solve rigid body planar kinetic problems. Before we go on to our main topic for today, let's just have a quick review kung ano yung dinadiscuss natin last lecture video. So last lecture video, we talk about the part 2 of the kinetics of particle work and energy. Kumbaga, we just discussed the principle of equations of motion in planar kinetics using principle of rotation about fixed axis and general plane motion. Kumbaga, nag-formulate tayo doon or dinerive natin kung paano ba kunin yung mga equations of motions kung yung mga particles natin is in motion, is rotation about a fixed axis, and also mga equations of motions din kung paano ba i-solve kung yung particle natin is in general plane motion, which is a combination of rotation and translation. And also we solve some problems related to equations of motion in planar kinetics, rotation about the fixed axis, and general plane motion. So basically, para siyang related lang or connected or continuous lang sa topic natin ngayon. Okay? So, our lesson contents for today's video. So, it's your kinetic energy, the work of a force, and the work of a coupled moment. Kumbaga, kasi yung lesson 8 natin is supposed to be discussed for 2 weeks. So, for this week, hinati-hati na lang natin kasi meron 5 topics na kailangan i-discuss under sa lesson 8 rather. And then, for today's lecture video, we're just going to discuss the 3 first topics, your kinetic energy, the work of a force, and the work of a coupled moment, related then sa planar kinetics of a rigid body, involving work and energy. And the learning outcomes, so dapat nyo ma-explain the analysis of planar kinetics of rigid body using principle of work and energy. Discuss the kinetic energy of a body subjective to translation, rotation about the fixed axis, and general plane motion. Discuss the work of a force and coupled moment, and solve problems about the work of a force and coupled moment. Okay? So, let's start with the kinetic energy. And alam natin kung ano tong kinetic energy. But ano yung kinetic energy enters sa planar kinetic of a rigid body? So, in this lesson, or in this topic specifically, we will first derive or obtain kinetic energy formulas on a body that is subjected to translation, rotation about a fixed axis, or general plane motion, or the combination of the two. And then, consider the rigid body shown in the figure. Ito, yung slab natin. So, which is represented by a slab moving in inertial axis. This inertial axis ng rigid body mo, or slab. XY reference plane. And then for the derivation, consider a randomly selected ith particle within the body, having a mass dm and is located a distance r, itong distance natin, from the arbitrary point P. Basically, ito yung ith particle natin. So, ito yung dapat natin i-consider or need nating alamin kung ano ba yung kinetic energy formulas na madederive natin using this ith particle. And then if we found or if we find kung ano yung kinetic energy formulas ng particle natin, then We just have to integrate that one to identify the whole rigid body or yung ano natin, slab natin. Okay? So if at the instant shown the particle has a velocity v sub I, ito yung velocity ng ano natin, and then its kinetic energy is, alam na natin, no? T for your kinetic energy is equals to a half of the product of the mass times squared of the velocity, di ba? So 1/2 mv squared. Or, since we are talking about the ith particle which has a mass of dm and it has a velocity v sub I for its ith particle na ninonote natin. So that will be 1/2 dm v sub I squared, no? Or when integrating, ito yung makukuha natin. So t is equals to 1/2 of the integral of dm times v sub I squared integrated from m to the upper limit. Ayan. So, equation 1, or itong equation na to, can also be expressed in terms of the velocity of point P, considering that the body has this angular velocity, omega, and based on the figure, we have, ayan, so v sub I is equals to v sub P, yung velocity sa, point P, and we also have to consider the angular velocity, no? From our the angular velocity of the ith particle with respect to point P, no? So this will be our v sub I will be equal to v sub P plus v sub I over P over respect P, no? So that will be equal to v sub I is equals to v sub P sub x I plus, ayan, v sub P sub y j plus omega k, because your nasa z-axis yun, diba? Yung natin, angular velocity which acting on that, no? So times, or the cross product of x I plus y j. So just have to i-group natin. So bakit ba naging ganito? Sige. And this first and second term, walang problema, di ba? Kasi nga, meron silang each, But here, kailangan natin itong i-cross product, itong dalawang terms na to. So, so, omega k, cross product by x sub I, o xi, so that will be k cross I, di ba? Using right-hand rule na learn natin sa previous subject natin, that the cross product of k, or vector k, crossed by the vector I, that will be negative, diba? Negative j. Positive j, diba? Kasi nga, k to I, that will be j, diba? So, that will be double omega x j, okay? So, tignan lang natin yon. So, that will be omega x j, okay? Now, next term natin, that will be omega k times yj. That will be the cross product of, cross product of k and j to j, di ba? So, parang using right-hand rule, no? That will be negative I, okay? So, negative I, yan. So, that will be omega y I, no? Negative omega y I. So, that will be, meron tayong I dito. So, that will be omega y I. So, that will be yung, for our group natin, no? Yung I tsaka j. So, ano yung mga scalar quantities natin, or, so, coefficient ng natin, vector. So, that will be v sub p sub x, yan nga, I, minus. Kasi ito yung cross product natin sa k and j, di ba? Negative I. So, that will be minus omega y quantity times I. Plus, yung j naman natin, that will be v sub p sub y plus omega x j. Okay? So, I hope hindi kayo na-confuse doon. So, that will be Again, ang term na to is yung cross product ng omega k times x side. Okay? So that will be k cross I, that will be j. Okay? Positive j. Okay? So, di pa yan yung ano natin. So, we need to simplify that one. So, that will be square equation 2, then substitute to equation 1. So, square lang natin, ito. Then, we're going to substitute. Kasi nga, yung ano natin, yung kinetic energy natin, yung velocity natin doon is squared. So, we need to square this one. Diba? So, square both sides. That will be, yan. So, v sub I squared is equals to v sub p sub x minus omega y quantity squared plus v sub p sub y plus omega x quantity squared. No? In-squared lang natin, ha? So, that will be v sub p sub x squared minus, ayan, so, ano lang natin? Ano to? V sub p sub x minus y minus omega times y times v sub p times sub x minus omega y. So, ito yung product niya. Kaya na lang mag-compute kung paano ito kinuha, okay? So, that will be, just easy lang naman ito. Algebra lang naman ito. Diba? Or partial multiplication by itself, no? Squared. So, that will be v sub p sub x squared minus 2 v sub p sub x omega y plus yung second term squared natin. So, that will be omega squared y squared plus ito naman. So, squared ng first term, that will be v sub p sub y squared plus sum ng dalawa, that will be 2 v sub p sub y omega x plus squared ng second term, that will be omega squared x squared. No? So, combine like terms lang natin. So, that will be v sub p sub x squared plus v sub p sub y squared minus 2 times v sub p sub x omega y plus 2 times v sub p sub y omega x plus omega squared x squared plus omega squared y squared. Where your v sub p squared is equals to v sub p sub x squared plus v sub p sub y squared. So, this term or these two terms will be now equal to v sub p squared. So, that will be simplified, no? And then, for x squared plus y squared naman siya is for r squared. So, ito yun. X squared tsaka y squared. So, magiging omega squared times r squared na lang itong dalawang terms na to. Diba? Na-simplify natin to into further, simplification. So, that will be v sub p sub x squared plus v sub p, ito yung kanina. So, i-rearrange lang natin so that pag mamayang mag-substitute natin sa mga values ng dalawang terms ito, tsaka to, hindi tayo ma-confuse, no? So, that will be v sub p sub x squared plus v sub p sub y squared minus 2 times v sub p sub x times omega y plus 2 times v sub p sub y omega x plus omega squared times x squared plus y squared. So, substitute lang natin, no? So, that will be, itong dalawang terms na to, magiging v sub p squared minus 2 times v sub p. Copy lang natin to. Itong dalawang terms ito, that will be negative and positive. Plus, naging r squared na to, di ba? Kasi sinabi natin kanina na r squared is equals to x squared plus y squared. So, magiging r squared na lang siya, no? So, that will be your equation 3. Ayan. So, v sub I squared is equals to v sub p squared minus 2 times v sub p sub x omega y plus 2 times v sub p sub y omega x plus omega squared times r squared. So, let's just substitute this one into our kinetic energy formula, which is equation 1. So, from this one to this one. Diba? So, sinubstitute lang natin yung value ng v sub I natin. V sub I squared na natin. Accounted na yung angular velocity natin with respect to our point P or ating point of, ayun, so P. So, na-consider na natin or na-account na rin natin yung angular velocity ng slab natin kasi nga it undergoes a rotational movement or motion, no? So, that will be 1/2 times the integral of dm times v sub p squared minus 2 eto, no? So, that will be your T now, or your kinetic energy. Yan, simplifying further na, distribute natin yung integral of dm, half of integral of dm each term sa inside ating quantity or sa ating bracket. Okay. So, distribute lang each terms, no? So, this will be your result, no? So, simplify pa natin further, that will be 1/2 v sub p squared integral of dm minus v sub p sub x times omega integral of y dm plus v sub p sub y omega times integral of x dm plus 1/2 omega squared integral of r squared dm. So where the first integral on the right represents the entire mass of the body when evaluating that integral. Yeah, basically ito lang yung baga whole mass ng ating slab kasi nga yung differential differentiate natin from m to its our upper limit. So ito yung baga yung whole mass ng object natin. Kasi nga itong dm is only for the particle, ith particle. Ito lang yung dm natin. So if we want to know the whole mass of this slab, we're just going to integrate that one, which is denoted by our first equation. So ayan, no? So that will be, if we integrate that one, is equals to 1/2 v sub p squared m, no? So that will be your whole mass lang yung integral natin dito. And then if we multiply that one into 1/2 v sub p squared, that will be your kinetic energy in the first equation, or your, the first term, no? Ayan, so, in-arrange lang natin to your m2 para natin yung kinaugalian natin sa kinetic energy na always first your mass. Okay? So for the second and third integrals, locate the body center of mass g with respect to p, and that is, yan, so y bar. Diba? Ito yung maglo-locate ng body's center of mass, diba? When we see this one, alam na natin, ito yung mga coordinates or location ng ng body's center of mass, or yung g natin, no? Ito yung maglo-locate using the inertial coordinate, no? Yung mga value na to is just going to locate your body's center of mass. So that will be v sub p sub x omega times y bar times m. Okay? And also the second term or third term, this is your second and third, which is going to locate again the body's center of mass. And the last integral represents the body's moment of inertia, IP, computed about the I sub p to class, computed about the z-axis passing through point P, and that is eto, di ba? Medyo familiar na to kasi when we talk about we talk about the moment of inertia. Ito yung formula niya. So, if you recall that one, it is only the moment of inertia I sub p computed about the z-axis na passing through sa point P natin, kumbaga papunta sa inyo, okay? Or papunta sa likod. Either way, basta z-axis, okay? So that will be equal to 1/2 omega squared integral of r squared dm is equals to 1/2 of omega squared I sub p, or the moment of inertia. So, thus, substituting it to equation 4, we get, eto na yung final na natin form. So that will be, wala na siyang integral, no? So that will be T, or the kinetic energy, is equals to 1/2 mass times velocity of point P squared minus v sub p of the component, or the horizontal component of our velocity on our point P. So that will be negative, So that will be negative v sub p sub x times omega times y bar m plus v sub p sub y, that will be omega times x bar m plus 1/2 of the moment of inertia at point P passing through a point P, no? So that will be times the angular velocity squared. So that will be, there is a special case when point P coincides with the mass center G of the body, then y bar is equals to x bar is equal to 0. Hence, the equation 5 will become, di ba nga, yung x bar tsaka y bar natin is used to locate the body's center of mass. So, meron tayong special case na yung point natin is andon sa, or point P natin, andun din sa body center of mass G. So, wala na siyang, bali 0, 0 yung origin niya from point P to G. Kasi nga, if other point na andun sa G, meron talaga siyang value ng x bar tsaka y bar. We all know that. Well, obviously, no, kung Yung special case na sinasabi dito is when your point P is nasa G din. So, your Y bar tsaka X bar will become to 0. Therefore, your equation 5 will reduce or will become now to this one. So, 0 na tong X bar tsaka Y bar, di ba? So, wala na tayong second and third term. So, mawawala na tong ito tsaka ito. So, that will be, matitira na lang dito is 1 half M times V sub G squared plus 1 half I sub G the omega squared. Okay? Now, na-change na yung ano natin kasi nga with respect to the bodies of mass center of G na, di ba? Kasi nga, point P lang dito, di ba? Other points na hindi andon sa G. Now, we say that a special case lang ha, equation 6, na if your point P is nasa G, ito yung kinetic energy mo. Okay? So, 1 half M V sub G squared plus 1 half of I sub G angular velocity squared. Okay? Both terms on equation 6 are always positive since V sub G and omega or the angular velocity are squared, di ba? Anything that will be squared, positive. No? So, also in equation 6, the first term represents the translational kinetic energy referenced from the mass center and the second term represents the body's rotational kinetic energy about the mass center. So, ano yung sinasabi natin? Kasi nga, your translational is when your body or your rigid body or your ano po itong materials mo dyan or any object that moves on a straight line, no? Kasi nga, meron tayong force, di ba? Tapos pinush natin doon. Tapos yung pag-displace niya is on a straight line path lang. So, that will be call natin, ito yung tawag natin na translational kinetic energy. So, that will be computed its kinetic energy to be 1 half mass times the velocity of the object that moves, no? Square that one, then you can have your translational kinetic energy. Kumbaga, sinasabi lang natin dito na yung equation 6 na to, is your first term is your tinatawag natin na translational kinetic energy and your second term will be rotational kinetic energy. No? So, madaling salita, okay, yung second term natin is when your body, kasi nga, dalawang ano nang nangyayari dito, diba? Dalawang motion yung nangyayari dito. Yung object mo na nag-move sa translational, tsaka yung meron din siyang rotational na nagaganap simultaneously. So, para makuha natin yung kinetic energy sa whole na motion ng object natin after we apply a certain force or external forces doon sa object natin na i-cause to move both translational and rotational, then we can have that kinetic energy by summing the two of the motion na ano natin, translational plus rotational. So 1 half M times V sub G squared plus 1 half I sub G angular velocity squared, then you can have that, your kinetic energy of the whole system. Okay? So, ganun lang. So, himay-himay natin kung ano ba yung mga nandun sa translation tsaka rotation tsaka yung general plane motion. Kasi nga, tatlong, di ba? Tatlong ano natin, planar motion natin nga, di ba? Meron tayong tatlong planar motion. Yung translation, yung rotation about the fixed axis, tsaka yung general plane motion. So, let's talk about translation. Kung ano ba yung nangyayari sa translation natin, no? So, when a rigid body of a mass M is subjected to either rectilinear or curvilinear translation, as shown in the figure, the kinetic energy due to rotation is 0. Since wala siyang, walang rotation, so walang angular velocity. So, wala tayong angular velocity or your omega. So, kasi nga, wala siyang rotational movement. So, the kinetic energy of the body is therefore, yung simple lang natin na nakukuha, di ba? So, that will be T, or kinetic energy, is equals to 1 half M times V sub G squared plus 1 half of the moment of inertia times the angular velocity na sinabi natin na wala siya kasi nga hindi siya nag-rotate or wala siyang rotation movement, no? So, therefore, your kinetic energy, kung yung object mo ay nag-move ng translation, either rectilinear tsaka curvilinear, no? Pa-curve siya or straight line path, no? Either way, ito yung gagamitin mong kinetic energy to solve the kinetic energy. Ito yung gagamitin mo na formula to solve the kinetic energy of that object. Okay? So, how about rotation about the fixed axis? So, when a rigid body rotates about the fixed axis, passing through point O, as shown in the figure, the body has both translational and rotational kinetic energy. So, that is, eto na yung gagamitin natin, yung dinerive natin. Given that your velocity is at the body center of mass, so makukuha natin yan. So, ito yung gagamitin natin, what we have derived, no? After we put some special cases, yung mga na-apply natin yung what if yung point P natin is na coincide sa G, ito yung na-derive natin. Alright, so from the kinematics, we know that V is equals to R times angular velocity, or V sub G is equals to R sub G times angular velocity. Substituting it to the equation above, we have ayan. So, para ma-uniform naman, di ba? Para hindi natin kailangan mag-compute pa sa V sub G, then you can just have the angular velocity, then multiply that one by the R sub G, or the distance from point O to G. So, you can have your kinetic energy na hindi ginagamit yung velocity talaga. Ginamit lang natin dito is yung mass, yung radius, or the distance between the two, O and G, times the angular velocity, tsaka yung moment of inertia. Tsaka, so walang involved na velocity talaga. We don't have to compute that one using only the angular velocity. Now, simplifying and rearranging, so after we substitute the value of the V, nagamit yung angular velocity, so that will be 1/2, no? Pinactor out lang natin yung angular velocity, di ba? So that will be 1/2 times I sub G plus MR sub G squared times the omega squared. Applying the parallel axis theorem, no, kung nakalimutan nyo na, then you can just review down. Basta yung parallel axis theorem, the terms inside the parentheses represent the moment of inertia I sub O of the body about an axis perpendicular to the plane of motion and passing through point O. So, basically, yung I sub O natin is yung yung nasa loob ng parenthesis. So, magiging simplified pa yan. So, thus, equation 8 can be simplified into I sub G plus MR sub G squared. Substitute natin kasi nga equal lang to sa parallel axis theorem na yung moment of inertia at point O with respect to G. So that will be I sub O is equals to I sub G plus MR sub G squared. So that will be T is equals to 1/2 I sub O omega squared. So, para kung makuha pala natin yung kinetic energy when your body experiencing rotation about the fixed axis, so makuha lang natin or masosolve lang natin using 1/2 of the moment of inertia at point O multiplied with the square of the angular velocity of our body. Then you can have your kinetic energy. No? Note that equation 9 still accounts for both the translational and rotational kinetic energy of the body. Okay? Involved pa din yung translational kasi nga dinerive natin dun sa velocity natin na dinerive natin kung ano ba yung equal doon when we are talking about the yung kinematics natin na in-apply natin yung kinematics natin doon. Then sa point pa lang nun na ginamitan natin na kinematic, then involved na talaga ng translation tsaka rotational kinetic energy of the body. So ganun lang. So when your body or your rigid body is experiencing some rotation about the fixed axis, dalawa talaga yan. Translational tsaka rotational. So ito yung gagamitin mong formula to solve the kinetic energy. Okay? So, next is the general plane motion. Ano naman to kung yung object mo is experiencing general plane motion. So, when a rigid body is subjected to both translation and rotation or general plane motion, no? Basically, magkano lang yung tawag. Shown in the figure, ito yung figure natin. So, it has an angular velocity omega and its mass center has a velocity v sub g. Okay, ito yung mga given natin doon. So, thus, the kinetic energy is this one. Kasi nga, meron siyang rotational tsaka translation. Okay? So, ito pa rin yung generic na formula natin when we are talking about kinetic energy kung dalawang motion yung nandun. Okay? So the equation above can also be expressed in terms of body's motion about its instantaneous center of zero velocity. No? Na-discuss na natin to sa lesson 7 natin to. Yes, lesson 7, sa part 1. Part 2. Anyways, basta na-discuss natin to. Anyways, ang ano lang niya, so ang kinetic energy lang niya is ato, no? The equation above can also again IC. So, yan. 1/2 of I sub IC omega squared. Okay? Ito lang, kumbaga. Then, if you're I think medyo fresh pa yung ano nandito when you're going to watch this one kasi nga na-light yung ano natin, yung problem set tsaka yung assignment, no? So, I think familiar pa kayo neto sa I sub C. I sub IC. Okay? So, moment of inertia of the body about its instantaneous center. Okay? So, ito lang. Kung baga, if general plane motion, ito yung gagamitin mo. If your rotation about the fixed axis is 1/2 I sub O omega squared, and then if translation or either rectilinear tsaka curvilinear, your kinetic energy will be computed as 1/2 mv sub g squared. So, ano lang. Okay, so ganun lang yung kinetic energy sa tatlong planar motion natin. So, again, sa translation, sa rotation about the fixed axis, saka yung general plane motion. So, meron silang sari-sariling formula solving sa kinetic energy. So, let's proceed for the part 2. Ano naman itong the work of a force? Ano naman itong mga work of the force kung yung nasa planar kinetics, no? Planar kinetics of rigid body. So, this lesson shows the different formula of work which depends on the type of forces encountered in the planar kinetics problem. So, you're probably wondering kung bakit, ano ba to, sir? So, ito is what we call the soil compactor. Kasi nga, it involves the rotational, best example when we are talking about planar kinetic, no? Meron siyang translation kasi nga mag-move to in a straight line. Siya yung gagawa na maging straight yung road, di ba? Kasi nga mas bigato, soil compactor, di ba? So mas approximately flat talaga yung madadaanan niya. So we can assume na it's moving in a straight line path. Tapos saan ba yung rotational movement doon? So yung rotational naman is yung wheels tsaka yung etong cylinder, the soil compactor itself. Ito yung soil compactor natin, tsaka ito yung vehicle, no? So, again, dalawang dito, best talaga example is soil compactor when we're talking about planar kinetics. Kasi nga, it involves translational tsaka rotational motion ng isang object at the same time, no? So, ito yun. So, these work formulas can be first work of a variable force, work of a constant force, work of a weight, and work of a spring force. Sige, sa discuss natin sa kinetics of a particle, di ba? Yung lesson 7, di ba? Ito yung mga work na kailangan natin i-account when we are talking about the whole work sa lahat or mga exterior forces na nandun sa object natin. So, ito yung mga work na dapat natin i-consider. If yung force mo ba is variable or constant, kailangan din natin i-account yung work of the weight itself, no, sa object natin, tsaka yung spring kung meron mga spring na involved doon. Okay? Ito yung dapat kailangan natin i-note kung when we are talking about work. No? So, let's talk about the variable force. So, ano yung work if your force is variable? Ano ba yung work natin? So, if an external force F acts on a rigid body, shown in the figure, ito, and may mga forces na nag-act natin sa body natin, the work done by the force when the body moves along the path S, ito yung S natin, tsaka ano ba yung work natin dito? So, U sub F, that will be equal to integral of F times dr is equals to integral or dot product of dr is equals to integral of f cosine theta ds. Okay? So, ito yung gagamitin mong formula kung yung force mo is variable. So, kailangan natin, when we're talking about variable again, it will be involving integration. No? So, ito yung formula natin to solve for our work sa variable force. Okay? So, where your theta is the angle between the tails of the force and the differential displacement. So, ito lang. Tail ng work ng force mo, assume mo lang na yung arrow dito is lumagpas dito, tsaka ito yung tail niya is nasa point talaga dito. So, tail din sa ds mo, ito yung arrow natin na blue, tsaka tail niya is andito din sa point na to. So, tail ng force tsaka tail ng displacement, that will be your theta. Okay? Same thing with this one. Kasi nga, nag-translate siya or nag-move siya at this initial position tsaka final position. Okay? So note that the integration of equation above must account the variation of the force's direction and magnitude. So again, kailangan natin i-account yung direction. So if opposite yung dalawa, negative. Now, if sila, collinear, then positive. Okay? So kailangan din na-account natin yung direction at magnitude niya. Lalo na sa magnitude, no? So, kasi lang dito, ninonote lang na kailangan natin i-note natin na yung direction niya if your work is negative or positive. Okay? So what about the constant force? Ano naman itong constant force? So, walang problema kasi constant force natin. Hindi na natin kailangan mag-integrate. Kasi constant yung force natin. So, if an external force, F sub c or constant force, acts on a rigid body shown in the figure and then maintains a constant magnitude f sub c and constant direction theta. I think this is not f sub c, dapat s na siya. Anyways, the constant magnitude, this will be s, and constant direction theta. While the body undergoes a translation s, then the equation 1 can be integrated, then the work becomes this one to this one. So, ganun lang kasimple. So, f sub c cosine theta from initial position 0 to s kasi nga hindi pa nag-move. So, that will be 0 at saka final position niya, the s. So, your u sub f of sub c, no? U sub f sub c is equals to f sub c cosine theta times the position or the final position or the difference between the two. Okay? Of the two positions, no? Ito yung initial niya, tsaka ito yung final position niya. So, ito yung pag-solve ng work mo. Okay? Okay. So, next is the work of a weight. So, ito mga weight, then of course, we're going to account of one. So, a weight of a rigid body does work only when the body's center mass G undergoes a vertical displacement. So, if hindi siya nag-displace vertically or vertical displacement niya, but downward or upward, wala kang work done for the weight. Okay? So, that would be, if the displacement delta y is upward, as shown in the figure, the work is negative because the weight is opposite to the displacement. Diniscuss na natin to. If, opposite direction yung force tsaka displacement, your work will be negative. And if the opposite, of course, or otherwise, it will be positive. So, that will be negative. Okay? Weight times delta y. Okay? Likewise, if the displacement is downward, then your delta y will be negative. Then the work becomes positive. So, that is ito. Again, negative yung work mo if your delta y will be upward, no? Or displacement of the body from this position to this position. If from this point of view, yung work mo dito is negative. If this is your initial position, ha? Ito yung parang pale blue. Ito yung initial position mo, tsaka yung darker blue, ito yung final position mo. Yung work mo is negative. If yung baliktad naman, if your darker blue will be your initial position and the pale blue is your final position, that will be positive work. sa weight. Okay? Take note lang. Basta ang importante, alam nyo kung paano i-compute yung work ng weight nyo. Just the weight of the body or the object times its displacement. Okay? Take note, vertical displacement ha. Hindi yung horizontal na displacement. Iba yun. So, if you're going to work to talk about weight, your displacement or your S will be dapat vertical displacement. Okay? Next is the work of a spring force. So, if a linear elastic spring is attached to a rigid body, then the spring force F sub S is equals to K times S or the coefficient of stiffness ata. Ito yung K, okay? Acting on the body does work when the spring either stretches or compresses. So, if wala doon, if hindi siya nag-stretch at compress, then walang work. Malamang, kasi nga, wala siyang force na may-apply doon kung hindi mo i-stretch or compress yung spring mo. Silbi ng... Anyways, from S sub 1 to further position S sub 2. Okay? So, the work will be negative if the displacement of the body is in the opposite and the direction of the force eitherwise positive. Okay? Again, the work again will be negative if the displacement pagod na lang to, basta opposite yung displacement tsaka direction ng force mo, that will be negative. And then otherwise, hindi positive, no? It can be computed using this formula. Negative, again, we already dinerive na natin to sa last or previous lesson natin. Bakit naging 1/2 S squared to or 1/2 K S squared natin. Dinerive na natin doon. So, that will be negative times 1/2 K sa S sub 2 squared minus 1/2 times K S sub 1 squared. So, yeah, ito yung gagamitin mo. Basta, yung meron kang reference point mo. Kung pa left, that will be negative. Then pa right, that will be positive. Okay? So, that will be, if, ang magiging, kasi dito, if your S and your force or the displacement in the force is pareha ng direction, but the work of the spring force will be positive and otherwise it will be negative. Basta ang importante i-memorize nyo itong formula na to. And anyways, simple lang naman ang formula na to, then you can answer. Ayan. So S sub 2 will be greater than S sub 1. Kung ito, if otherwise, then positive, then wala tong negative na to. Okay? So, that will be the computation of the work of a spring force. Now, meron din tayong tinatawag na mga forces na hindi nagwo-work or walang work. Basta ganoon, ito yung forces that do no work. So, your work is equal to 0. So, note that there are some external forces that do no work even when the rigid body is displaced. So, meron talagang mga external forces natin na hindi or walang work kahit nag-displace pa yung body mo. Now, these forces usually act either at a fixed point on the rigid body or having the direction perpendicular to the displacement. Kasi nga, cosine theta, if your theta is 90, that will be cosine 90, so that will be 0. So, wala kang work. Kasi nga, Fs cosine theta, yung natin, di ba? Yung general formula talaga when we are solving work. So, if you input to your calculator of cosine 90, that will be 0. So, wala kang work. Okay? So, ito sabi dito, may dalawang reason kung bakit wala siyang work. Either yung forces mo is nag-act sa fixed points on a rigid body or hindi siya nag-move or wala siyang displacement na nangyari kasi nga fixed points. So, ayun, first reason mo yon. Then, second reason is kahit nag-displace pa yung object mo or your rigid body, if that force is having a direction perpendicular to the displacement, okay? Kung yung direction ng force mo is perpendicular sa displacement mo, then wala kang work. Or wala yung work. Okay? Hindi ikaw. Yung force. Okay? Basta yun. So, kung dalawang reason lang yan. Yung object is hindi siya nag-displace or perpendicular yung direction ng force mo sa displacement niya. So, example, No? Weight of the rigid body when its center of gravity moves in a horizontal line as shown in the figure. So, ang ano nito is para siya na movement sa screen. When you're facing your screen right now, the movement of your or of our this circular disc is right, okay? So yung weight mo, again, 'di ba ang sinabi natin doon kanina ng work of weight is the vertical displacement. Dapat vertical displacement yung ano mo. So wala siyang vertical displacement kasi nga horizontal line ng movement niya or displacement niya. So wala siyang up and down na movement. So sabi natin kanina, walang work if walang vertical displacement. So that is that is example of forces that do no work. Okay? Or weight does no work here. Okay? So that's example. Another example. Example ba natin? So reaction at pin support about which a body is rotate. Okay? For example, ito yung support natin. And then yung yung ano natin, yung ito yung support natin Ito yung tatawag natin na pin support. So kung yung body mo is magro-rotate lang na ganyan, ganun na movement, wala siyang work doon. Okay? If meron man siyang work, baliktad. Dapat pa daw basta, ang ano natin dito is nag-move siya pa counterclockwise If dyan lang siya, or meron siyang fixed point na nag-rotate doon, or kahit anong body pa yan, wala siyang work. Or yung reaction ng pin mo doon. Okay? Wala siyang tawag doon. Wala siya. Ito yung mga pin support natin Let's say for example, ito yung pin natin, tsaka ito yung mga reaction ng pin mo. Either this is called, let's say, A natin this is A sub Y, tsaka A sub X, no? Ito yung mga reactions. Siguro naman kayo sa statics, diba? So, meron mga reactions ng pin natin, ng A sub X and A sub Y. Then, if that body will rotate at that fixed position or fixed support or pin support, then wala tong mga work. Okay? Kasi itong A sub Y is force, no? Force tong A sub Y tsaka A sub X. Ito yung mga forces or mga reactions or when say reaction forces yun, di ba? Okay? So, wala siyang work, no? Kung dun lang or dun yung body na nag-rotate. Basta mayroon tayong example mamaya kung bakit or clear na representation kung bakit zero yung mga support natin or reactions na sa support natin. Anyways, that's another example. Another example is the normal reactions acting on the body or on a rigid body that moves along a fixed surface. So, ayun nga. If fixed surface mo or anyway, basta fixed yung surface mo or ano ba tawag nun? Hindi siya nagbabago. Basta normal reaction niya, ayun nga, kung fixed surface siya or hindi talaga nagbabago yung degree ng ano niya, then zero again. Your theta will be zero, then perpendicular lang din yung normal reactions mo sa, or normal reaction or your n. So, n cosine 90, that will be zero. So, wala siyang work doon. Okay? Another example is a frictional force acting on a round body as it rolls without slipping over a rough surface. So, walang slipping, then walang friction or walang force doon ng friction nag-involve. So, kung meron mag-exist lang yung frictional work ng friction mo when your body is slipping na over a rough surface. So, kung tabi dito without, then wala siyang work. Ano lang kasimple. Okay? So, these are example ng mga forces na hindi or walang work. Okay? I hope you did get some ideas there. No? So, let's proceed for the part 3. So, the work of a couple moment. So, meron din tayong work sa couple moment. Kasi nga, mention lang natin 4, di ba? 4 lang yung mention natin kanina, yung work ng variable force, work ng constant force, work ng weight, tsaka work ng spring. Di ba? So, meron din tayong tinatawag ng the work of a couple moment. I think na meron na kayong idea kung ano yung couple moment. Anyways, let's discuss this one. So, the work of a coupled moment. Now, consider a rigid body shown in the figure. So, ito yung figure natin. Assume na lang nakikita nyo dyan. So, in which it is subjected to a coupled moment. M is equal to F times R. Kasi nga, again, kung discuss natin doon, when we say, nga, moment, that would be your force, tsaka yung moment arm niya. Diba? That is really the, generally, formula, or, basta, ganun kasimple mag-compute ng moment. I-multiply mo lang yung force tsaka yung moment arm niya away from that point, no? So that will be your moment. So that will be M is equal to F times R. So if the body undergoes a differential displacement, then the work done by the coupled forces can be found by considering the displacement as the sum of a separate translation and rotation. So kung yung body mo is experiencing a differential displacement or nag-undergo ng differential displacement, then yung work done by the coupled forces can be found na considering natin yung displacement ay para siyang tawag doon, basta sabi dito sum of a separate translation tsaka rotation. Iba yung displacement ng translation mo tsaka iba yung displacement ng rotation mo. In-add mo yun, then yun yung baga differential displacement na kinost or in-exert ng coupled forces mo. Anyways, kung medyo na-confused, meron naman dito, further discussion pa. So when the body translates as shown in the figure, the work of each force is produced only by the component of the displacement along the line of action of the forces. So kung line of action is the horizontal, then yung concern mo lang doon is yung vertical, no? Kung when your body is in translation, di ba? So yung work mo lang or the work of each force is produced only by the component of the displacement along the line of action of the forces ds. Okay? So I hope that's Also as shown, the positive work of one force cancels the negative work of the other force. Kasi nga opposite sila, the same yung magnitude ng force, but opposite yung direction. Then cancel out lang din ng niya. It's kasi nga couple sila. Couple. Anyway, couple is dalawang forces na same yung magnitude but different or opposite yung nila, direction sa isa't isa. Okay? Couple na pero different yung direction. Anyways. So, when the body undergoes a differential rotation theta about the arbitrary point O shown in the figure, then each force undergoes a displacement ds sub theta is equal to r over 2 d theta. Diba? Baka yung baka ang r sub 2 is the length of the force from, kasi nga r, diba, yung distance ng f, tsaka yung f na to, f talaga. Basta distance ng isang force sa kakouple niya is r. Now, at point O, sa gitna, so therefore, yung length or yung arm ng f ng isang f is r sub 2. And isang f is r sub 2 left. Kasi nga, half lang ng r. Then, they can have that one. Then, yung ds or the displacement of that force, no, can be computed by using the arc length, diba? Ito yung arm niya, tas meron kang dito, angle dito, then multiply mo yung r over 2 times the theta, then you can have your displacement ds, diba? And the direction of the force, in the direction of the force, ha? So, eto din, para makuha mo tong ds na to, itong displacement na to, then you can multiply the r over 2 then times theta. Excuse. So thus the total work then is u is equals to fs. So that will be du sub m, or the differential work of the coupled moment is equals to 2 f ds theta. Kasi nga dalawa sila. Okay? So 2F. So du sub m is equals to 2F r sub 2 d theta. To compute this r ds. Kasi nga, dito, r over 2 d theta using Arclay formula. So that will be cancel out yung isa. So, kumbaga, consider lang natin yung isang f, tsaka multiply lang natin ng r tsaka d theta, then you can have your moment. Then, kasi nga, m is equals to fr kanina, so that will be m. So, magiging dum is equals to m d theta. Okay? Ito lang pag-solve mo. Then, equation 1, the work is positive when m and d theta have the same sense of direction and negative if they have opposite sense. Same lang pa rin yung ano natin. Parang rule of thumb natin, no? When we are dealing with the direction of the work or ano natin, sign ng ano natin, negative ba siya or positive natin. Baga yung ano natin, rule of thumb, no? Rule of thumb natin dito is positive yung work if your direction of the moment or force has the same sense sa direction nila, no? That will be positive. If opposite, then that's negative. Ano lang din dito sa couple moment. Basta ang importante, how to compute the work of a couple moment, then md theta lang. Ganun, okay? When the body rotates in a plane through a finite angle, theta, measured in radians from theta sub 1 to theta sub 2, the work of a couple moment is therefore eto. Integrate mo lang both sides. That will be theta sub 2 to theta sub 1. So, that will be, ayan. So, if the couple moment M has a constant magnitude, then we can have, ilabas natin kasi constant yung M. Therefore, your work of a couple moment is equals to the moment times the difference of theta sub 2 and theta sub 1. So, ganun lang. Ito lang yung formula mo to find the work of the moment. Okay? So, that's how you solve the work of a couple moment. So, ayan. So, meron na tayong another formula in solving the work. So, medyo madami na. Again, work of a variable force, work of a constant force, work of a weight, work of a spring force, and lastly, the work of a couple moment. So, let's have an example na ma-apply natin lahat ng work, including the moment or couple moment. So, kailangan natin i-apply noon or solve problems kung ano ba talaga yung parang scenario, no? When we are dealing with couple moment, spring, weight, tsaka other forces or axial forces na nandun. Okay? So, let's have an example. So, the bar shown in the figure has a mass of 10 kilograms and is subjected to a coupled moment of M is equals to 50 Newton meter and a force of P is equals to 80 newtons. Okay? So, which is always applied perpendicular to the end of the bar. Ito, perpendicular siya to the end of the bar. Okay? So, also, the spring has a stretched length of 0.5 m. So, hindi pa siya in-stretch, meron na siyang length na 0.5. Baga, ito yung original length niya. No? Stretch, unstretch, no? Original length ng spring kung unstretched is 0.5 meters and remains in vertical due to the roll guide at B. Ito yung roll guide natin. So, determine the total work done by all forces acting on the bar when it has rotated downward from 0 degrees to 90 degrees. So, ito yung theta sub 1 mo. Okay, theta sub 2. Okay, so ito yan. So, again, what is or determine the total work done all the forces, by all the forces acting on the bar. No? When it has rotated downward from theta sub 1, 0 degrees to theta sub 2 is equal to 90 degrees. Okay. So, first, given and record. Ano ba yung mga given mo? That's, yung bar natin is weighing or has a has a mass 10 kilograms. Moment experiencing sa bar is 50 Newton meter. Yung force natin will be 80 Newton. Yung S natin ng spring 0.5 meters and stretch siya na theta sub 1 is equals to 0 degrees, and theta sub 2 will be 90 degrees. Then the required is the total work done by all the forces acting on the bar. That will be U sub T. Okay? So solution, of course, draw the free body diagram to show all the forces acting on the bar. Meron tayong support or reaction at the support. Meron tayong moment. Yung weight natin. Yung force ng spring. Tsaka yung force na external force na nag-act sa bar natin. That will be 80 Newton. So yung weight is 10 kilograms. So that will be 10 times 9.81. That will be 98.1 Newton. To be determined po yung force ng spring natin. So compute the work done of each force that acts on a bar. So let's have muna the weight. Okay? So the weight is, we all know that it is computed by U sub W is equals to negative W times the delta Y. Okay? So as shown in the FBD, the weight is displaced downward by 1.5 meter. Thus, U sub W is equals to negative mg times negative delta Y. So that will be negative 10 times 9.81 meters per second squared, negative 1.5 meters. Kasi nga, downward to, di ba? Nag-displace siya downward. So negative yung displacement mo. Okay? So, your work of the weight is positive 147.15. And that's expected na. Kasi nga, yung movement or displacement ng bar mo is downward. And the same sense din sa direction ng weight mo, or which is downward always. So, kasi nga, caused by the gravity. So, negative times negative, that will be positive. So, positive yung work mo. Okay? Oh, wala. Hindi kayo nalito doon. So, next is the work of the coupled moment. So, again, to compute for the work of a coupled moment, that will be U sub M is equals to M times theta sub 2 minus theta sub 1. Note that theta must be in radians. Okay? Kasi hindi mo mamultiply yung N or Newton meter sa degree. So, kailangan natin i-rad. Okay? Convert mo lang yung ng mga degrees to rad para mamultiply natin without an issue. Okay? So, that will be 50 Newton meter times 90 degrees. To convert the degrees to radians, that will be pi over 180 minus 0 degrees times pi over 180 degrees. So, that will be 78.54 joules. Okay? So, positive siya kasi nga, same sense yung pag-change ng angle niya is pa downward, then moment natin is pa clockwise din or downward pa din. Or same sense lang talaga yung movement na displacement. Same sense yung direction ng moment tsaka yung displacement. Okay? So, that will be positive. Next is the work of the spring force. Yan. So, negative 1/2 ks sub 2 squared minus 1/2 ks sub 1 squared. So, substitute natin yung mga values. That will be 1/2, 13 Newton per meter. Ito yung K mo, or the coefficient of stiffness. Tawag technical term doon. So, that will be 30 Newton meter times 2.25 meters squared. Bakit 2.25? So, again, di ba, from our roller guide, ito yung roller guide natin nakakabit yung natin, spring dito, spring, pasensya na sa drawing, basta spring yan. So, from this one to this one, meron na siyang 0.75, di ba? Pasensya na sa, so 0.75 siya. Okay? 0.75 meters. Meters yan 0.75 or 0.75. Given that your unstretched length of the spring is 0.5, di ba? 0.5 yung unstretched length niya. Therefore, mas mahaba pa yung gap ng roller guide natin to our, or this one, or I don't know, Saan yung dito talaga yung 0.75 kanina. Ito yung sa support pin natin dito. So that will be 0.75, tapos yung 0.5 from the roller guide, that will be mas mahaba pa yung gap natin sa support to the roller guide. Therefore, stretch na siya na initially sa 0 degrees. So, at 0 degrees, ang initial position kasi natin is 0 degrees. So, ano ba yung na-experiences sa natin sa spring natin is 0.25 meters. Na-stretch na siya initially at 0.25 meters. Kasi nga, 0.75 minus 0.50, diba? 0.75 or 0.75 minus 0.50, the unstretched length, kasi nga, na-stretch na siya initially. Kasi nga, ang gap natin dito from our support natin dito sa roller support ng spring natin is 0.75 away from the pin or the support. So, medyo mahaba siya sa original or unstretched length ng ng spring natin. So, assume na sa 0 degrees ng bar or dito pa lang yung bar, okay? Initially, dito yung bar, diba? 0 degrees or hindi pa siya nag-move, no? So, na-stretch na siya ng 0.75 minus 0.50. Diba? Kasi medyo mahaba yung gap natin dito from our support eh. So, that will be 0.75 minus 0.50. That will be initially 0.25 meter. So, kung natatanong ko bakit 0.25 dito, that will be 0.75 minus 0.5. Okay? So, that will be 0.25. This is your 0 degrees. Okay? Stretch na siya initially by 0.25 meters. Now, for our 90 degrees naman, okay, nagtatanong kayo kung bakit 2.25 yan. So, at 90 degrees, na-stretch na siya. At this point, ito yung length ng spring natin when it's stretched by 90 degrees. So, ilan yung length dito? That will be 1.5 plus 0.5. That will be 2 meters, di ba? So, to have or to get the horizontal component of our horizontal ba? Yeah, horizontal ng component natin ng displacement ng spring natin, no? That will be your vertical component, okay? That will be this one, okay? Ang hinahanap natin dito, class, is yung length ng spring natin at 90 degrees. So, to solve that one, that will be 1.5 plus 0.5, that will be 2 meters. So, vertical component ng spring natin, that will be sine of theta, no? Now, your theta is 90 degrees kasi nga, yun yung final position ng spring natin. That will be sine 90, so that will be 1, no? Okay? So, sine 90 is 1, di ba? Sine 90 is 1. So, 2 meters times 1, that will be 2 meters. But, initially, meron siyang stretched length na 0.25. Therefore, that will be 2 meters plus 2.5. That will be 2 meters. 2.25 meters. So, ito yung final stretch ito yung length ng ng spring mo after it was stretched 90 degrees from the initial position. So that would be 2.25. So therefore, your work of the spring force is 1/2 or negative 1/2 times 30 Newton meter times 2.25. Again, this is the final position of the spring, away from its support. Okay? Away from its support. So that will be squared minus 1/2 30 Newton meter times 0.25 meter squared. So therefore, your spring force or work of the spring force is negative 75 joules. Again, displace niya is pa downward, but the force is force of the spring kasi nga babalik yan. In-stretch mo eh. So babalik yan ng original force, that will be upward na force. No? Babalik siya kasi nga in-stretch mo. So that will be opposite sa direction ng displacement mo. So that will be negative 75 joules. Note that the work of the spring force is negative because F sub S acts in the opposite direction to its displacement as shown in the FBD. Ayun, pa-upward yung ano natin dito. Okay? Always talaga draw the FBD and ng mga forces na nandun, and then be ano talaga cautious sa ano mo, pag draw ng line or arrows mo kung asan ba yung direction niya after mong mag-analyze ng problem. Pagbasa mo lang sa problem, alam mo na dito yung direction ng spring force ko. Ito yung direction ng weight ko. Ito yung direction ng force ko na andon na in-apply sa object ko, then safe ka na mag-compute ng work mo. Hindi mo na kailangan mag-ano pa. Okay? With the help of the FBD, then yun. FBD, okay? So, yan. So, next is the work of the constant force. Again, natapos na tayo sa couple moment, weight, tsaka yung spring force. And lastly, will be your constant force. Ano ba yung work ng 80 Newton mo? So, that will be U sub F is equals to Fs cosine theta. So, shown in the FBD, the force P is displaced by S cosine theta is equals to R theta sub 2. No? Kumbaga, yung 18 Newton mo is away from the fixed point, or its displacement from this one to this one. Ito yung displacement niya. Okay, initial position mo is this, tsaka ito. Ito yung displacement ng force mo. So, ano ba to? Okay? Ano ba yung displacement nito? Okay? Take note that this is only computed using the arc length formula. That will be length of the bar times the theta. Okay? So, thus, P times R times theta sub 2. Okay? So, that will be 80. Okay? Length of the bar is 1.5 plus 0.5. That will be 2. Plus 1 meter, that will be 3. So, ito yung, ano niya, R. So, 3 meters. Tapos, yung 90 degrees, ito yung theta mo is 90 degrees. That will be, and radians ha, when we are talking about arc length, dapat naka-radians yung angle mo. So that will be 90 times pi over 180. Then, the work of the constant force P is 376.99 joules. Then, we can have our, also, we have to take note also the force that do no work. Para ano naman natin, medyo mapipicture out natin kung ano ba yung mga forces na walang work. No? So, that for the actions at the pin A, it will be A sub Y and A sub X. Ito yung dalawa na to. Do no work since these forces are not displaced on or therefore fixed. No? Hindi siya nag-displace sa whole system natin. Hindi talaga siya nag-move, or either nag-move siya dito. Kung nag-move pa to, meron tayong work dito sa support natin. No? Kung mag-move siya pag ganon or pag ganon. So, meron siyang work. But, sa problem na to, hindi mention na nag-move yung mga react ng pin natin, pin A, so wala siyang work done. Kasi nga, wala displacement. Ano yung times mo yan? Kung walang displacement, 0. So, 0 yun yung work mo. So, the total work now will be U sub T is equals to the work of the weight, work of the weight, work of the coupled moment, work of the spring force, and the work of the constant force. Therefore, add mo lang yung mga na-compute natin kanina, so that will be 147.15 joules for weight, 78.54 joules for coupled moment, plus minus 75 joules for the spring force, and 376.99 for the force, or the constant force. So, total nun is 527.68 joules, or approximately 528 joules. So, this is your work, or the total work of your bar for all the external forces, or all the forces acting on our bar. So, ito yung work na produce ng weight mo, ng spring force mo, yung constant force mo, and also the coupled moment. So, this is your total work done. Okay? And up next will be the part 2 of the planar kinetics of a rigid body. So, meron po siyang continuation. Okay? So, the next lecture video natin, or next date na natin i-discuss. So, I hope you did learn something from this lecture video. Again, for the summary, no, na-discuss natin kanina yung kinetic energy sa each translation or on each planar motion. Ano ba yung planar kinetic ng translation when your body is centered translation only? Ano yung kinetic energy when your body is experiencing rotational about the fixed axis? And also we found also what is the kinetic energy or how to solve the kinetic energy when your body is in general plane motion. And also we discussed the work of the force, no? Ano yung mga work na paano ba i-solve yung mga work when your body is in rotational or in the sa planar kinetics? Ano ba yung mga work or ano ba yung mga work ng mga forces kung yung rigid body is in planar kinetics? So na-solve natin kung paano i-solve yung variable force, which is same lang din naman sa lesson 7 natin na discuss natin, although meron lang mga konting additional, yung couple moment, work done, work of a couple moment, work of a weight, no? Work of the weight, work of the spring force, work of the variable force, and work of the constant force. So again, yun lang ang discuss natin, and also we solve a problem, no? Na na-count natin lahat talaga na na-mention natin na mga forces na posibleng merong work, tsaka na-count din natin yung mga forces na posibleng wala ding work. So, ayun nga, I hope you did learn something for today, and thank you for listening. Okay?